Hi viewers, in today's class we are going to have continuation for antenna arrays. In previous class I have just given brief introduction about antenna array. Now this is continuation for that. See here in today's topic I want to discuss on antenna array field pattern control. So as already I have said, in order to obtain antenna field pattern according to our requirement, we need to use some 5 different types of methods, controlling methods that I am going to brief out for you. The first one is geometrical configuration, the second one phase excitation, third one amplitude excitation, fourth relative displacement, and fifth one relative pattern. We will see one by one. So in the first one we are saying that geometrical configuration. So in geometrical configuration we can choose any type of geometric shape like linear or spherical or rectangular type of shapes. So according to the shape of the antenna you have chosen or the shape of the arrangements you have done for the antenna array, its output will be obtained, that is your output radiation pattern will be obtained. In second case, phase excitation means, for example, we will be using like phase shifters. You can see in this diagram, this is transmitting antenna. Somewhere at this end we are having receiving antenna, and see here all these 5 symbol you can see, all these are the phase shifters. So according to our requirement, we will commonly link all these to a common shifter point. So whatever the amount of phase shift we want to introduce, we will introduce from this end. And see, you can observe all the radio waves are traveling in this direction. And the patterns, like actually this will be completely forming the lobes like this. All these gets added up in same direction, and finally your resultant pattern will be like this. You will be getting a narrow beam. So according to our requirement, without moving the actual position of antennas, that means no need to shift antenna's position or place, just you can change its phase. The antenna phase can be changed by using these phase shifters. This is one method or one way to control the output beam pattern. Or in the place of phase shifting, we can change the frequency also. Frequency changes also can affect the radiation pattern of an antenna. Next, the third point is regarding amplitude excitation. So amplitude excitation is also one of the method for controlling the shape of the radiation pattern. That means while you are changing, if these are the different antennas which we have arranged in the form of an array, say for example we are changing the amplitude, that means we are applying different types of amplitudes to each and every element. In that case also, based on the total amplitude, the antenna output pattern shape may be changed. For example, the pattern shape can be controlled like this. According to our requirements, the pattern shapes will be changing. Next, the third one is relative displacement. It is also one of the way to control the radiation pattern. Like for example, we can see the radiation patterns outputs will be like this. This is just example only. So in this diagram you can see 4 major lobes, and I want to show one more diagram like this. Here you can see 2 major lobes. So these are the 2 peaks you can observe here. So by changing the separation between the elements or distance between the elements, the output radiation patterns will be changing like this. That means the output radiation beam can be controlled by adjusting the separation or spacing between the elements. This is also one of the controlling method of the radiation output pattern. The last one is relative pattern. Actually we have already said that the total output radiation pattern is nothing but the vector sum of field patterns and individual antenna elements. That means for example here we have taken 3 antenna elements. So the total field strength pattern means it is nothing but the summation of individual field patterns. So always the field pattern summation should be in a constructive manner. That means add up of fields, not in a destructive manner. So Here, for example, I need output radiation in forward direction, means all the fields should be get added in forward direction, and in reverse direction or backward direction I don't want any radiation, means what should happen in backward direction, the destructive manner should happen, then only a small side lobes will be appearing. These type of beam can be obtained only through any one of these controlling methods. So totally 5 different ways we are having for controlling the output radiation pattern in antenna arrays, and these all of the methods what I have said are very easily applicable in practical way, right? Next we are going to see how, applications of antenna arrays. See here I have listed out a few applications. The first one, satellite communication, military radar communication, wireless communication, astronomical study, and 5G technology. So nowadays we are hearing about all of these type of outside applications, and practically just I have given 3 examples. Monopole array is used for AM broadcasting, whereas Yagi Uda array is used for television signal reception. Log periodic dipole array is used as usual for TV antennas, right? So these are just a few examples regarding the antenna array applications, and here these are specifically using the antenna array concept for their outputs, right? Next we will have a just glance on types of arrays. So basically phased and non-phased array are the fundamental classification of the antenna arrays. In that, phased arrays means whenever you are going to use your antennas as a group, if among the antennas you are going to introduce the phase shift or phase differences, then they belong to this category. And if you are not using or applying any type of phase difference, and you are just using your antennas in a normal arrangement one by one like this without applying any phase shifts, it comes under the category of non-phased array. But basically mostly practical case we are using the phased array type of antennas. And again sub-classification we are having broadside array, end-fire array, collinear array, and parasitic array. So these are the mostly used type of array antennas in outside world, and along with this some more type of arrays are also there, but these are popularly used. Thanks for watching.